Hello and welcome to another video discussion. And today in this video, we'll talk about climate change. The greenhouse effect is a natural process that warms the Earth's surface. When the sun's energy reaches the Earth's atmosphere, some of it is reflected back to space and some is absorbed and re-radiated by greenhouse gases. Greenhouse gases include carbon dioxide, methane, nitrous oxide, ozone, and some artificial chemicals such as chlorofluorocarbons or CFCs. The absorbed energy warms the atmosphere and the surface of the Earth. This process maintains the Earth's temperature at around 33 degrees Celsius warmer than it should be otherwise, allowing life on Earth to exist. Here's an illustration of the process. For the first step, solar radiation reaches the Earth's atmosphere and some of this is reflected back into space. After that, the rest of the sun's energy is absorbed by the land and the oceans hitting the Earth. Now, heat radiates from Earth toward space. And then, some of this heat is trapped by greenhouse gases in the atmosphere, keeping the Earth warm enough to sustain life. Human activities such as burning fossil fuels, agriculture, and land clearing are increasing the amount of greenhouse gases released into the atmosphere. And this is trapping extra heat and causing the Earth's temperature to rise. In this graph, based on the comparison of atmospheric samples contained in ice cores and more recent direct measurements, provides evidence that atmospheric carbon dioxide has increased since the Industrial Revolution. And from the graph, it's clear that the increase in the carbon dioxide level is unprecedented and may continue to rise. Because of the global warming, the evidence for rapid climate change is compelling. First, here, we can see that the planet's average surface temperature has risen about 2.12 degrees Fahrenheit or 1.18 degrees Celsius since the late 19th century, a change driven largely by increased carbon dioxide emissions into the atmosphere and other human activities. Most of the warming occurred in the past 40 years, with the 7 most recent years being the warmest. The years 2016 and 2020 are tied for the warmest year on record. The oceans of the world are also warming up. Their average temperatures pushed higher and higher each year by human-caused global warming. Only about 1% of all the trapped heat has stayed in the atmosphere, but it's had a huge effect, warming up the air by Earth's surface by about 1 degree Fahrenheit or equivalent to 0.6 degrees Celsius on average over the past 2 centuries. Most of the rest of the trapped heat has been absorbed into the planet's vast oceans. Since the 1970s, the oceans have soaked up more than 90% of all the excess heat energy trapped by CO2. Because the oceans are enormous, and because water takes much more energy to heat up the air or heat up than the air, that translates to a temperature increase of a little more than 1 degree Fahrenheit on average over the past century. But the warming is speeding up. The top part of the ocean is warming up about 24% faster than it did a few decades ago. And that rate is likely to increase in the future. Every little bit of warming, however small, has enormous impacts on marine life, storm intensity, and more. Ice shelves are floating ice connected to the mainland. They receive ice from glaciers flowing into them from the mainland and from accumulation from snow directly onto the ice shelf and from seawater freezing onto the bottom of the ice shelf. Most mass loss from the Antarctic continent is from ice shelves, and most of this is from just a few small ice shelves around the Antarctic Peninsula and West Antarctica. Ice shelves can collapse dramatically. This can occur over just a few weeks, following progressive thinning by warm ocean waters below and from excessive melting during warm summer above. If an ice shelf collapses, it changes the boundary conditions for the glaciers that flow into the ice shelf. This means that ice shelf tributary glaciers accelerate, thin and recede following ice shelf collapse. So, although ice shelves are already floating and therefore do not contribute to sea level rise when they collapse, ice shelf removal has significant consequences for the grounded glaciers on the mainland. A glacier retreats when its terminus does not extend as far down valley as it previously did. Glaciers may retreat when their ice melts or ablates more quickly than snowfall can accumulate and form new glacial ice. Higher temperatures and less snowfall have been causing many glaciers around the world to retreat recently. Snow cover, or the area of land that is covered by accumulated snow at any given time, helps regulate Earth's surface temperature when it is present, and it helps fill rivers and reservoirs once it melts away. Snow cover reflects about 80 to 90% of the sun's energy back into the atmosphere, allowing it to help regulate the exchange of heat between the Earth's surface and the atmosphere, thereby cooling the planet. While snow cover affects climate, changes in climate also affect snow cover. Overall, warmer temperatures are shortening the amount of time snow is on the ground in the northern hemisphere. Recent temperature increases in the Arctic have also led to decreased snow ice and cover in many areas during parts of the year. And they've also led to earlier melting of snow cover, which is changing when and how much water is available in some rivers and reservoirs, as well as lengthening the growing season. Because changes in snow cover can severely impact Earth's environment and ecosystems, as well as people's access to water resources, scientists continuously measure how much of the planet is covered by snow. In the long term, this record will help scientists understand how snow cover and Earth's climate are changing. And in the short term, it can help water resources managers assess and plan for each spring's snowmelt. Global sea level has been rising over the past century, and the rate has increased in recent decades. In 2014, global sea level was 2.6 inches above the 1993 average, the highest annual average in the satellite record, 93 to present. Sea level continues to rise at a rate of about 1/8 of an inch per year. Higher sea levels means that deadly and destructive storm surges push farther inland than they once did, which also means more frequent nuisance flooding. The two major causes of global sea level rise and thermal expansion caused by warming of the ocean and increased melting of land-based ice such as glaciers and ice sheets. Polar ice caps are melting as global warming causes climate change. We lose Arctic sea ice at a rate of almost 13% per decade. And over the past 30 years, the oldest and thickest ice in the Arctic has declined by a stunning 95%. If emissions continue to rise unchecked, the Arctic could be ice-free in the summer by 2040. An extreme event is a time and place in which weather, climate, and environmental conditions such as temperature, precipitation, drought, or flooding rank above a threshold value near the upper or lower ends of the range of historical measurements. To date, climate research has yet to show that any given event was caused solely by global warming. However, over the past decade, research has demonstrated that climate change due to global warming has made many extreme events more likely, more intense, longer lasting, and or larger in scale than they would have been without it. For many of the events that have been studied, global warming has been identified as the primary driver of the event, now just a supporting player. And a number of recent studies have concluded that certain heat-related extreme events would not have been possible without human-caused global warming. Ocean acidification is sometimes called climate change equally evil twin, and for good reason, because it's a significant and harmful consequence of excess carbon dioxide in the atmosphere that we don't see or feel because its effects are happening underwater. At least 1/4 of the carbon dioxide released by burning coal, oil, and gas doesn't stay in the air, but instead dissolve into the ocean. Since the beginning of the industrial era, the ocean has absorbed some 525 billion tons of carbon dioxide from the atmosphere, presently around 22 million tons per day. Well, at first, scientists thought that this might be a good thing because it leaves less carbon dioxide in the air to warm the planet. But in the past decade, they've realized that this slowed warming has come at the cost of changing the ocean's chemistry. When carbon dioxide dissolves in seawater, the water becomes more acidic and the ocean's pH level drops. Even though the ocean is immense, enough carbon dioxide can have a major impact. In the past 200 years alone, ocean water has become 30% more acidic, faster than any known change in ocean chemistry in the last 50 million years. Many chemical reactions, including those that are essential for life, are sensitive to small changes in pH. In humans, for example, normal blood pH ranges between 7.35 and 7.45. A drop in blood pH of 0.2 to 0.3 can cause seizures, comas, and even death. Similarly, a small change in the pH of seawater can have harmful effects on marine life, impacting chemical communication, reproduction, and growth. Now, with all those presented evidences, climate change is really that scary. The impacts of climate change on different sectors of society are interrelated. Drought can harm food production and human health. Flooding can lead to disease spread and damages to ecosystems and infrastructure. Human health issues can increase mortality, impact food availability, and limit worker productivity. Climate change impacts are seen throughout every aspect of the world we live in. However, climate change impacts are uneven across the country and the world. Even within a single community, climate change impacts can differ between neighborhoods or individuals. Long-standing socioeconomic inequities can make underserved groups who often have the highest exposure to hazards and the fewest resources to respond more vulnerable. Understanding the effects and teaching about climate change can be a daunting challenge, but it is a critical field for students to learn about as it affects many parts of society.